got a chopper. All right, so a helicopter. Please don't my drawing.
On.
For example, yep.
We're still staring at Word.
Oh, sorry, me bad. All right, my bad, my bad. Hang on a second. Thanks for letting me know, John. Appreciate it. Okay, so visualize your question. So you sketch a helicopter. It doesn't have to look like a helicopter. Well, something like mine. Okay, so let's say I've got a helicopter. I don't know. How does it look like? Here. Okay, so let's say I've got a helicopter like that. Okay, now, so I don't know, whoever that is. All right, now. What did it say? So a helicopter is flying at a constant altitude of 91 meters. So altitude. Now the word altitude means height. Now in aviation terms, aviation means well anything that is flying in the sky. Now, so altitude means the height. They won't probably say height. They'll normally say altitude. They use the word altitude. And altitude is the height from sea level. Okay, so the altitude or height is 91 meters. Okay, so and the question says sights the middle of a landing pad. So sights the middle of the landing pad at an angle of depression of 16 degrees. So let's draw, so pause right there. That's a landing pad. Let's draw a landing pad. Let's say, for example, the landing pad is somewhere around there. Oh my goodness. Right now. So a landing pad, you know a helicopter landing pad, right? A helicopter landing pad has a H on it, okay? All right, do you know why it's called H? It's because I own it. It's corn. Now, never mind. So that's a helicopter landing pad. All right. So sight means the pilot is looking at the landing pad. Now, of course, if the pilot is flying the chopper at 91 meters above the sea level, how is he going to spot the landing pad? Of course, he's going to tilt his head down, right? So when he tilts his head down, or her, sorry, it must be equal. Her head down, then is it angle of elevation or is it angle of depression? What do you reckon? Which type? What type of angle? With
Depression.
Depression. Very good. Depression. All right. Now, so what you can do is now see this is the power of visualization. Is that you can draw a line like that.
Mister,
Yep.
Grace said she can't hear you.
Oh, sorry, I didn't see the chat. He said if we can't hear, tell him. Okay, yes. What's happening there? Sorry, Grace. Grace, can you still hear me or not? Pop it on the chat. Can you still hear me? Yes or no? Is she still there? Grace, can you let me know if you can hear me? Maybe her internet's dropping out, or maybe my internet's dropping out. Maybe her internet is dropping out. Yeah, she's trying to reconnect. Can you guys hear me? Because you're not really responding to me. I don't really know. Can you guys hear me?
Yeah, I can hear.
Can you hear me clearly? Okay, so it's not my internet then. Yeah.
I can hear.
Can you guys hear me clearly? Okay. All right. Cool. Grace, what about you? Okay, so now, well, what was the question again? Where was it? So it says that, well, it sights the middle of the landing pad. So the middle, can you see that? So sights the middle of the landing pad. All right. Now, at an angle of depression of 16 degrees. All right, now, Norman, angle of depression of 16 degrees, what does that mean? So it means that, well, when the pilot is looking downwards, the angle of depression, so the angle, the theta is how much?
16.
16 degrees, very good. So how exactly are we going to draw that? Now I'm just going to remove this figure here so that it is it's not distracting of diagram here. So 16 degrees. So if, let's say for example, the eyes of the pilot's right there, okay? All right, can you see that? So the eyes of the pilot's right there. So that means the angle of depression, so his eyes is supposed to be what? Horizontal, isn't it? That's what we call the eye level. So that means the eye level is supposed to be horizontal. True? It's supposed to be horizontal. But since he's looking downwards, since his head is tilting downwards, so that means the angle of depression, which is right there, isn't it? So that's the angle of depression. Do you agree with me? So that's the angle of depression, and how much would that be? The theta is going to be what? 16 degrees. True? Okay? All right? Does it make sense? Does it make sense? Does it make sense? All good there? Are we following? Yeah? Yeah, Denise said yes? Okay, so from there, what can you see? What can you see from there? So, do you see a right angle? So you can actually form a right angle triangle, right? So what I'm going to do is I can actually put a straight line across. So from the middle of the helicopter pad, the helicopter landing pad, all the way up. I'm trying to draw a very straight line here. Trying my very best. Okay, so if you put a line across, it forms a right angle triangle, doesn't it? So you can put a right angle right there. Does it make sense? All right? Okay? Lisa, you following? Are you following? So how far in meters must the helicopter travel to be directly over the landing spot at an altitude of 91 meters? So the question is asking you how far the helicopter is going to travel so that the helicopter is sitting right there. Okay? The helicopter is sitting right there. Oh my God, seriously, the drawing. So the helicopter is sitting right there, right on top of the helicopter landing pad. So how far is it going to travel? So what does the question, what's the question asking for? The question is asking for the distance, isn't it? So the distance from there to where? To here, isn't it? Right? So if we extract the whole situation out and turn it into a very simple diagram, instead of putting the helicopter, the landing pad right there, all we could do is we could transform that whole problem into a very simple problem that looks like that. It's just a right angle triangle, okay? Right? You got the theta, which is how much? Your theta is 16 degrees, okay? All right, so your height or your altitude is how much? 91 meters. So that means that length, that side length over there, this one from here to here is 91 meters. Do you agree with that? Okay, so what the question wants you to find is the side length of this, isn't it? Let's give it x. Okay, so x equals to I don't know how much. Okay, so how are you going to find the distance then? So how far in meters would a helicopter need to fly? So all you need to do is to find what? The side length. That's it. Okay, so now you tell me. You've got 91 meters there. Your reference angle is right there. That's your theta. So tell me what's 91 meters?
Oh.
Oh, very good. It's opposite. Excellent. Now, what about that? Is that hypotenuse adjacent?
A.
A. Very good. You got an O, you got an A, you got the theta, two sides with one angle, O and A, sine, cos, tangent. Which one?
10.
10. Very good. So you grab 10, so tangent. So tangent theta. What's theta? What's tangent theta? What's theta? Theta is 6. Isn't
O
it?
over A.
Tangent. Yep. Tangent 16 degrees equals to opposite over adjacent, isn't it? So opposite 91 over what's adjacent? A over X. That's what we're looking for, isn't it? So how are we going to find X? So what should we do? How are we going to find X?
Chuck it to the left.
Check it to the left. Very good. Excellent. Like a quick answer right there. Well done. So check it to the left there, and that becomes what? X 16 degrees equals to 91. Isn't it? Okay. So X tangent 16 degrees equals to 91. Now, so that means what's X? X equals to?
91 over 10, 16.
Very good. 91 over tangent 16. So all you need to do from here to find the final answer is to grab your calculator. Now, ladies and gentlemen, let's press the calculator together. Okay. Now, it's still not working. Says there's a problem, but I don't know what it is. Grace, I don't know. I'm sorry. Try turning off and on the microphone again and see if it works. Otherwise, I can't really help from my end. I'm sorry. Okay. I might discuss this question privately with you later. Okay. So now if you press the calculator like that, so all you need to do is you go 91. Okay. So hope that you can see that. Is it clear? Okay. So 91 divided by tangent 16. So 91 divided by tangent, so tangent 16, and then hit equal. So 91 divided by tangent 16, that's what's the answer? 30. Jesus. So 300 and what?
17.35.
317. So 317. Oh my God.
0.35.
17.35. So 317.35 meters. And that's going to be an approximate sign instead of equal. Okay? So that means, now remember I've told you before, now once you've got the answer, always fit it back in here. It's a good practice. So that means the distance from there to there is 317, approximately 317.35 meters. Okay, so that is the distance that a helicopter has to fly to get directly on top of the helicopter landing pad. Okay, all right. Okay, all done? How's everybody? Did you understand that? All good? Yep, the answer good. Okay, so excellent. All right, now let's move on to the next example. Now, who needs more time to jot that down? Who needs more time? Can you please let me know? Either by turning on your microphone to respond to me or to pop it in the chat. Oh, God. Okay. All right, now, so I'll give the what? Everybody done with this question? Can I move on to the next one? Yeah? Yeah, nah, kind of. I want to know it's morning, but you gotta let me know.
Yes.
Yes, yes. Okay, I'm trying to sort it out now. Okay, all right, cool. All right, now, so let's move on to the next question. Right, the next problem is here. So share screen, let's put it there and here. Okay, now let's work on the next example. So example 2, so E dot G2, now example 2. All right, now let's copy the question here. Let's have a look. So a swimmer, 0.32 kilometers from the base of a cliff, looks up and waves to her friend. Let's put a swimmer, Denise, 0.232 kilometers from the base of the cliff, looks up and waves at, I don't know, waves at who? Dion, who is at the top of the 110-meter cliff. Find the angle of elevation from the swimmer to the top of the cliff. Yeah, I wonder if he could see her. Oh, sorry, she could see him. Oh, Denise might need glasses, I don't know. Now, nearest degree. There we go. So a swimmer, Denise, 0.32 kilometers from the base of the cliff, looks up and waves at Dion, who is at the top of the 110 meters cliff. Okay, so find the angle of elevation from the swimmer, so from Denise to the top of the cliff. Give your answer to the nearest degree. So what would that be then? Let's analyze the question. All right, you guys done what? Norman, you done?
Not yet.
Not yet. Honey, you done?
Yeah.
Yeah. Okay. Dion. All right, I need to look at my screen for Dion. All right, now, Dylan, are you done with the question? Dylan there. Dylan, where are you? Are you there? What about you, Dion? Have you completed the question or what? Okay, yep. Yep, excellent, Denise. What about you? Alyssa? Alyssa?
Yeah, I'm done.
You're done? Cool. Denise? Yep, Denise said she's done. All right, Norman? Done?
Done.
Excellent. Good job. All right, now, let's proceed. All right, so I'm going to stop sharing that so they can see the board. All right, now, so let's analyze the question. So, what's the question here? So, swimmer Denise is 0.32 kilometers from the base of the cliff. So, pause. Now, see, this is how you analyze a word problem. If it's a long word problem, break it down into tiny snippets or chunk. All right, and try to extract as many information as possible from that sentence itself. So in this sentence here, the first sentence, the swimmer Denise, 0.32 kilometers from the base of the cliff. There is information there, isn't it? Okay, so that means, well, there's a line there, okay? That would be the ground. So that's ground level, okay? So Denise is where? It's 0.32 kilometers from, sorry, that won't be the ground. So she's from the cliff. So let's say that's the cliff. Okay. So she is 0.32 kilometers from the cliff. Okay. So Denise is right there in the ocean. So I'm trying to, well, this is tricky. I'm going to draw the ocean like that. All right, yeah, like that. Okay. Yeah. So Denise is right there in the water. Okay. Now, so the distance there is 0.32 kilometers. Okay. So now, what's next? What's the next sentence? Looks up. So Denise is looking up and waves at Dion, who is at the top of the 110-meter cliff. Oh, pause. There's a lot of information in there. 110 meters cliff, meaning to say from there to there is how much? 110 meters. Okay, so immediately visualize it, put it in the diagram. Okay, so Denise is 0.32 kilometers out from the cliff. Okay, so she's in the ocean swimming. Okay, now, and Dion was right there. Okay, so Dion is 110 meters on top of the cliff. Okay, so what Denise is doing there is that Denise is waving at Dion. Hello, like that. Okay, so Denise is in the ocean swimming, and then she looks back and waves at Dion. All right. Okay. Now, so find the angle of elevation from Denise to the top of the cliff. So the angle of elevation of Denise to the top of the cliff. Okay. So that means what the question wants you to do is to look for this angle here, isn't it? Oh my God. All right, now. Okay, so from...
Sorry for the interruption, everyone. Mr. Whippy, if you're in the school, can you please contact the front office?
So from Denise's eyes, what Denise is looking at Dion from the ocean. All right, now what is the angle of elevation? So that means what's that angle right there? Okay, does it make sense? So what I would like you to do now is to transform that into a simple diagram. So that diagram there is literally what? A right angle triangle that looks something like that, isn't it? So I'd like you to transfer the situation here, the problem here, into a very simple diagram. All right, let's do it. I'll give you a couple of seconds to do it, okay? I'll give you a couple of seconds to do it. All done or what? So what should I put here? What goes here? What's the site length? Norman, what do you reckon?
0.32.
Very good, 0.32, excellent. 0.32 kilometers. Okay, now what about the site length over here? Lisa, tell me, what's the site length over here?
110
110, very good. 110 what?
meters.
Meters. Whoa. There's 110 meters right here.
Stop.
Hey. Hi, Grace. Good, fixed it. All right.
I had
so,
to restart the computer.
oh, yeah, go. Good on you. Glad it's working. So there's 110 meters over here and 0.32 what? Kilometers over there. Now, do you know why every time when you write a measurement, I ask you what? 0.32 what? 110 watt, right? The unit of measurement is really important, isn't it? Right? It's very important because that's kilometers and that's meters. Can we put them into the equation like that?
No.
No, we can't.
No.
Exactly. So you either turn 110 meters into kilometers, or you turn kilometers into meters, isn't it?
Meters.
320. Isn't it?
Yeah, okay, so if you prefer meters, you can convert that. So 1 to 3, so that's 320 meters. So it depends on what unit you prefer. You could convert that into kilometers if you wish. Okay? Now, so what about the angle of elevation? The angle that Denise uses to look at Leon, who's on the cliff. Okay? So how much is that? Now I'll let Denise answer that. I'll answer this. Denise, what's the theta?
I don't know.
I don't know. And I don't know is the correct answer because you are looking for theta, aren't you? You're looking for the angle of elevation. Right? Okay? So now let's do it. Okay? So right angle is right there, your reference angle is right there, your theta is right there. So what does that make 110?
H.
Woo!
H? Oh, no. O.
Oh, very good. Okay. Now, what about 320 meters?
A.
A. Okay, very good. Ooh, O and A. So sine, cos, tangent.
Toa.
10.
Is that Toa? Toa.
Yeah, tangent. So very good. So 2. So tangent. So 10. Tangent what? Tangent what?
Theta.
Theta. Very good. Tangent theta equals to
110 over 320.
320. Very good. 110 over 320. Now, immediately I see zeros there. I'm going to just simplify real quick straight away. All right? Are you following? So 110 over 320. I see zeros on top, zeros on the bottom. See you later. Simplify. Okay? Now, so tangent theta equals to 11 over 32. Now, what are we looking for? Norman, what are we looking for? You tell me.
Angle of elevation.
Angle of elevation. Very good. Okay, so we're looking for the angle of elevation. We're looking for theta. So how are we going to get rid of 10? How are we going to get rid of
Arcs. Arc 10.
Arc tangent. Very good. Arc tangent. So arc tangent. So what I'm going to do is I'm going to pop arc tangent in front of it, isn't it? So I pop arc tangent in front of it. So that would get rid of 10, isn't it?
Yeah.
Yes.
So if you put arc tangent on the left-hand side of the equation, you got to do the same.
You have to put on the right.
On the right. Very good. So you pop an arc tangent on the right too. So that brings us to the next step, which is, oh my God. Now, theta equals to arc tangent 11 over 32. Now, ladies and gentlemen, what's next? Tell me what's next.
Press the calculator.
Calculator, exactly. Very good. So grab, oh my God. Now, so grab a calculator. All right, now we're going to start pressing. So just remember how to press arc tangent. So all you need to do is
Shift.
Yep, shift, and then you click on
Tangent.
All right, so you get an arc tangent like that, and then you go open bracket 11 over or divided by 32. All right?
Yes.
Okay, there we go. So arc tangent 11 divided by 32. So the answer that you get is 18.97. Okay? 0.0781. So 18.97 degrees. So 18.97 degrees. And of course, that has to be approximate. Okay? So now let's transfer.
Yes.
Remember, it's a Very good. So remember that's a very good habit for you to transfer the information back onto the question. So theta equals 2, or approximate to 18.97 degrees. So
Yay.
we can conclude that. So we can conclude that while Denise is swimming happily in the ocean, she turns around, looking at Dion, who is on top of the cliff at an angle of elevation of 18.97 degrees and wave. And you know what Dion's gonna do to Denise? Dion's gonna say, thumbs up. Okay? Now, so are we all following that question? Do you understand?
Oh my god, yes. Yes.
Yeah? Okay, cool.
Alyssa, I just gotta say yes. Yes, just yes.
Come on. You know what? We use you as an example next. How's that sound? Okay.
Mister, that's mean.
Yeah. And I'll leave the other actor to you guys. You guys tell me who that's gonna be. All right. Now. All right. Now. So, ladies and gentlemen, all good there? John, Norman, up.
Yeah.
Yeah. Yeah. Cool.
Yeah. Yeah.
Yep.
Norman. Guess what?
Nothing.
Mick.
What? Oh, okay. All right. Now, Lisa, all good? Yeah, I suppose she understands that because she was making fun of me. Denise should be all right because she is one of the characters. Dion? Yeah, I reckon Dion will be fine. Yeah, he's just gonna give me a thumbs up anyways. All right, now, Grace, what about you? You didn't. Do you understand this question here, Grace?
Oh. Yeah, I think so.
I think so. All right, cool. Let me know.
I can work it out. I can work it out. I have big brain.
Oh yeah, sounds good, eh? Big brain, big head.
Yes.
Yeah. So,
She'd
honey,
be right.
all good?
Yeah.
All right, excellent. All right, cool. So, yeah, I reckon that's it. So that's it for now. Now, what I'd like you to do is to the questions in booklet 2. I realized that I only gave you 4 questions in there. So, well, that's a discount for you, isn't it? Well, that's supposed to be 15 questions, but since there are only 4 questions in the booklet because I somehow accidentally left the other questions out, well, that means you can do less. Okay? All right. Well, take it as
Thanks,
a
Mister.
All right, now. So what I'd like you to do, well, consider that this as your homework is booklet 2. Okay, booklet 2, exercise 7.5. There's 4 questions right there. Question 1, question 4. Now, the other one that I would like you to do is booklet 1. Booklet 1.
Mister.
Yes.
I can't find my booklet 1. I don't know why. I've looked throughout my whole bag and everything, and it's not there.
Uh-oh, that's not good. Is there any chance that you might drop by at school? I can pass it on to you. Otherwise, don't worry about it. Now,
I don't know. I'll see.
yeah, let's see. Let me know, okay? So booklet 1, question 1 to 6. I think it's only 1 page. And booklet. Now, if you have booklet 3, now booklet 3 consists of many quality and challenging questions that some of you might be interested in. So if you do have booklet 3, you can do page 151 to 155 question. So that's question 1 to 9. That will really, those questions will really tickle your brain. Okay? It does.
I don't want my brain to get tickled. That'll feel weird.
What? He said that she has mega mind. I'm waiting for somebody to say I've got giga mind. All right, now.
You said it yourself.
Oh, no, not me. All right, now, so booklet 2, that's your main course. Your main course, booklet 2, exercise 7.5, question 1 to 4. And then if you have booklet 1, that's your appetizer, okay, question 1 to 6. And then last but not least, you've got a dessert, okay, page 151 to 155, question 1 to 9, okay? And a meal won't be perfect without 3 courses, okay? All right, now, so I reckon that's all for today. Now, here's an offer, okay? You don't have to accept it. I was just thinking about it. I thought that some of you might be interested. It's not compulsory, but please let me know if you're interested, okay? Now, so you know next week's holiday, isn't it? Like the real school holiday.
Yay!
Okay? You can turn on your microphones now, all of you, if that's easier for me to have a chat with you or have a discussion. Okay, so you know next week's our school holiday, isn't it? Now you have officially completed all your Year 9 trigonometry. I was thinking if you're interested to do the advanced trigonometry. Now remember when, in the first lesson, when I introduced Trigo to you, I just quickly draw a very simple flow chart here to remind you on what I said before. So remember in the first lesson of Trigo, I told you that there are 2 types. I don't know how many of you still remember that. So there's the first type where you have a right angle trigonometry. So right angle trigonometry, right angle triangle. So trigonometry for right angle triangles, and there is.
I wrote this down.
Yeah, and there's non-right angle triangles.
Yes.
Yep. So I
Yes.
believe that I have taught you this before. Now, and I have also taught you that, well, in year 9 or up to year 9, you only learn the right angle triangles, the trigonometry for right angle triangles. Now, here's an offer on the table. You can take it, you don't have to take it, it's not mandatory, it's optional, but for those of you who are really interested to find out the non-right angle triangles. Now, so trigonometry for non-right angle triangles, you'll learn it in year 11 methods. I have already gone through that, okay? I believe if you have been following all the lessons about trigonometry for right angle here, and plus, you guys already know how to rearrange the formula right here. So you've got a really solid foundation right there. You know how to rearrange the formula. You know how to solve the equation. You know the friends and the go to hell thingy. Okay. So and you have already learned how to use trigonometry on right angle triangles. Now I've gone through the topics for non-right angle triangles. I think it'll be simple for you. And I believe that, I highly believe that you can do it. It doesn't really matter whether it's year 11 or not. But of course, just an offer. If you'd like to take out the challenge, please DM me, let me know. Okay? So if
Will this be online?
Hey?
Will this be online?
Yeah, this will be online. Yeah, because we can't really come to school during the holidays. Yeah, this will be online. I reckon 2 or 3 sessions will do, really. 2 sessions. I'll grab this book and show you.